Let's start with a simple trig problem to get us started today. We have a right triangle, an angle in that right triangle. We have a distance, and we want to find another side. Well, we would start by labeling the sides of this triangle with respect to this angle. So if you look at this angle, this is our opposite, this is our adjacent, this is always our hypotenuse. So we've got the opposite and the adjacent. Tangent ratio is opposite over adjacent. Tangent of 32 is therefore going to be the opposite side divided by the adjacent side. I'm going to isolate the x. By multiplying both sides by 2.3, I've simplified using my calculator. .4, and that's in meters. Let's say we wanted to apply this to a real life situation. Suppose we wanted to measure the height of the CN tower. We already know the height of the CN tower, but let's say we wanted to double check, see if it's shrinking, or maybe they didn't build it as high as they said they did. Well, we could do a little experiment in real life. But we wouldn't be able to use a measuring tape or anything like that because it's just such a huge distance. It's not practical to make a measuring tape that big. It would be too heavy. It just wouldn't work. So let's say you were standing outside the CN tower and you were able to calculate a distance and an angle. If you had those two pieces of information, so the angle looking up at the top of the CN tower down to the bottom of the CN tower, and the distance from the base of the CN tower to where you're standing, we could use trigonometry to figure out how tall the CN tower is. So let's suppose you were standing 200 meters from the CN tower and looking up at the CN tower, it made a 70-degree angle. This is a right angle because the CN tower is at a right angle with the ground. So once again, we could use the tangent ratio as we did before. And here we're getting 549 meters, which is approximately the height. So we call this angle the angle of elevation. Sometimes it's called the angle of inclination or ascent. If you measure an angle going down, like you're at the top of a hill and you're looking down at something, we call that an angle of depression because it's down from the horizontal. Angles of depression are sometimes called angles of declination or descent. So there's a few words that can be used to describe these two types of angles, but they're the same idea. So let's say you were trying to find the height of a tree. Let's say that's your tree and you are standing here. And you have a device that will give you an angle, and you're holding it, you're standing here, and you're looking up at the tree. It's going to measure this angle for you. Let's say that this angle is 25 degrees. And let's say that you stood back from the tree, let's say 20 meters. And you're holding this device that measures your angle at eye level. And your eye is about 1.5 meters off the ground. We want to figure out what the height of the tree is. So if we look at this diagram, we've got a triangle, we have a rectangle. The triangle, we have a distance and an angle. So we can solve that triangle. We could figure out what this height is. I can call that height x. We could solve that triangle just like we did before using the tangent ratio. So we get 9.3 meters, and we know actually that this is 1.5, and so h is going to be 9.3 plus 1.5, which is 10.8 meters. So those of you paying really close attention may have noticed that in the example of the CN Tower, we kind of overlooked this distance. We didn't really factor this in, and that's true. It was kind of an estimation, so we're kind of off by a little bit. So we didn't really factor in the height of the person.